Reverse means. This is where you have the mean of some numbers and you have to try and work out what the numbers were. Slightly more complicated than getting a mean. Gets lots of points. Lovely jubbly. Reverse means normally we have the sample data and we find the mean. So we have three heights, A, B and C. What is the mean? Well, the mean height is A plus B plus C divided by the number in the sample, 3. So that's that. Three children have heights 90 cm, 100 cm and 110. What is their mean height? Mean height is 90 plus 100 plus 110 divided by 3 equals 3 over 100 equals 100 centimetres. Trouble with this is it's very boring. It is boring with a capital B, and it will not get you very many marks, even if they ask the question at all. So, examiners being examiners, they create something a little bit more interesting called the reverse mean. Here you know what the mean is before you start the question, and you have to find something about the sample. If the mean height of a sample of 3 heights is 100, then this is what you've got to think about. Then the total height is 3 times 100 equals 300 centimetres. This is the key to solving all reverse mean questions. Reverse means always go through the total. What does that mean in practice? Well, 3 children have a mean height of 100 centimetres. Who'd have thought it? 2 of their heights are 90 centimetres and 100 centimetres. What is the height of the third child? Seems a bit familiar. If the mean height of a sample of 3 is 100, then the total height is 3 times 100 equals 300. But we know the heights are 90, 100 and x. X is the unknown third child's height. So 100 plus 90 plus x is 300, and you can fiddle it about to get x equals 110. You've gone through the total to find the answer. And that's the only way to do it. So let's look at this question that cropped up recently. Here is the key. In the first 5 weeks, the mean mass of the runner beans Sean picked was 4.2 k, where we've got 4.2 kilograms. We've got the weights of the others, but we know what the 5-week mean is. So we know that the mean of 5 samples is 4.2. The total mass of the 5 samples is 5 times 4.2 equals 21. Right, well now we're rocking. We have the first 4 samples. The first 4 samples equals 3.6, 3.4, 2.9, 5.1. Well, I do it in parts really. These 2 add up to 7, these 2 add up to 8. Total's 15. The 5th sample therefore is the total of all the samples, 21, minus the 4 samples we know about, and that equals 6. As you can see, this is a 4 marker. Very little calculations, but the trouble is, if you've not done this before, you're probably stuffed. These are the sort of questions that make people look clever, not because they are clever, but because they've seen it and they've done it before. And that's a key distinction. This is the solution. This is a bit overtaxing. You're not going to go straight in. Build the question. Find the total. Find the 4 you know and subtract. Anyway, I hope that's helped. So, to summarise, think, is this a reverse mean question? Find the total, and the total is the mean times the sample size. Then, you go around the houses. Then find the total of the known samples. Then find the missing sample. Does your answer give the mean in the question? It's always the check. Does your answer satisfy the original conditions? Anyway, this is a hard question, and I hope it's become easy. I think it's easy once you know how, like a lot of things. If you've enjoyed this, why not subscribe? And if you haven't enjoyed it, why not subscribe? If you're having an exam soon, best of luck.